Hello everyone, my name is Johnny Mates and I will be presenting our project one for CECS 327. So just a little background real quick. Our system is made from a cluster of Docker containers. They're all built using this image, which pulls from the latest Ubuntu image. And for each Docker container, it contains all these files plus the network client and the network server Python scripts. So I will now go ahead and start our cluster. And the way we do that is we do docker compose up. And docker compose, this file right here, lets us build and port map all our Docker containers. Really easy. Puts them into a default network where if we go here, we can see, here we go, all of our containers are up, the names, the ports they're mapped to, the default routes, and then if we wanted to check the network information, you'll see right here, this is our default network that all our containers are in. Here's the subnet and the gateway to that subnet, and then you will see information about all the containers in our network, all our IP addresses, names, all that. Okay, so the way our cluster works is you have to do a docker execute command into each container, and this will put us in the shell for each of these. And then we just simply do Python 3 and then net server.py. Oh, wrong command. Embarrassing. There we go. And you'll see that our Docker container shows our IP address for that container. And so we're just going to go ahead and run that in all of our containers. You can see we get a different IP address every time. Perfect. Now we're going to go ahead and start our client. And this is our script for that. Everything's in Python. We use asynchronous communication using the async IO library. We also use socket, pandas, Docker is used. And for our server, we just use async IO and socket. And so we are going to go ahead and demonstrate this now. So here's is our computer, and you can see this is all the IPs of the Docker containers we have. So it's going to ask us which protocol we'd like to use. We're going to do broadcast first. And we're going to do, hey everyone. And you'll see that the data sent was our message, hey everyone. And so if we go over here real quick, we'll see data received, hey everyone, hey everyone. So all of our containers successfully got that message. Not only that, but they sent back a message. So here, right here, you'll see send hello from server, so on, and it gives you our IP address. So each of these containers sent something, and our client server received all of that. So you see data received, hello from server, so on and so forth. Okay, pretty cool. I want to know everyone's favorite animal. So we're not gonna close it yet, and we're gonna do broadcast again. What is everyone's favorite? I say color or do color? What is everyone's favorite color? Okay, so server 1 likes blue, server 2 is red, server 3 is green, and 4 is neon orange. Okay. What about, let's see, keep it going. I now want to do a multicast. And I want to know what's everyone's favorite season. Mine is fall. And we're going to send that to group. Let's do group 5. Okay, so server for their favorite season is football season. I guess that makes sense. Server two, oh no, sorry, yeah, server three is spring, and server two is winter. Okay, we'll do another multicast. And we'll say everyone's favorite OS. I like Linux. I do, even though I'm on a Mac right now. And we'll send that to group. Send it to group one. Okay, so server one and server two, both, no, server one and server three, these are their favorites. I'll do one more broadcast. I want to ask this question to everybody now. Do broadcast and same thing. Okay, server one's Linux as well. Server two is Windows. Three is Mac OS, and four is Collaborate. Container four is definitely having a day. It seems they're into some weird stuff. And yeah, that is our TCP connection between our client and our server. Thank you so much. And in order to stop this, we would just run. Oh, real quick before I forget, everything about the broadcasts that were sent are put into this results.txt. This is made so you can see uh, the first message we sent was a broadcast. Our source IP was none other than our own, which is the subnet gateway, if you remember. Source port was 8082. Destination was all of our servers. Our destination ports for all of our servers are 80. Let's make it easier. Our protocol was a TCP. The length of our message was 61 bytes. And you can see our first message was, hey, everyone. And it does the same thing for multicast as well. So here we go, type multiclass, source IP, source port, destination IP. Now you'll notice there's more than one answer for this because we are sending to groups in each in a single broadcast. Protocol is TCP, length is 94, and there's our message again. So yes, the results text is generated at the beginning of the script, and it will just populate every time we send a broadcast. And yeah, like I said, in order to stop this, we just do a docker compose stop, and after that, our containers will shut down. Thank you so much.